Most CCNA graduates struggle to get a job after they complete their CCNA because majority don't have hands-on experience. And yet the industry is basically looking for CCNA graduates that have the necessary hands-on skills to be able to deliver when they get on the job. And sometime this week I came across a Reddit post where an organization hired a CCNA graduate, and when they got to work they were given a console to do basic configurations on the switch, and they were struggling with those commands, which left a few of the senior network engineers a bit shocked. How can you graduate with CCNA and not understand the basic commands that are required in order to get a switch functional? In this video, I'm going to be covering 10 labs that every CCNA graduate needs to complete in order for them to be employable. These labs basically cover 90% of what any junior network engineer is going to be covering on a day-to-day basis. So if you're able to complete these labs, you are going to be guaranteed that you can walk into any organization, walk into any interview, and be able to lift your hand up and say, I can do these. And I can assure you that you will get employed. By the end of this video, you're going to know the 10 labs that every CCNA must master, why the labs are very important, and the real-world applications that the labs are basically used. Hey, if we're meeting for the first time, my name is Tinei. I'm a senior network engineer, and I help aspiring network engineers gain hands-on experience. So if you're new here, you might want to subscribe. As I mentioned earlier on, one of the most challenging aspects is when people complete their CCNA, they tend to have theory knowledge. And let's face it, when you're focusing on your CCNA, priority is to try and pass the exam. And many times you tend to neglect the practical aspects of the certification. However, when you get into the industry, the ability to be able to configure and manage the actual Cisco devices that you're learning in your CCNA is very important. And I've had countless discussions with people that graduate, that are trying to get a job on the market, but they're struggling to get a job, and they're wondering, why is it that they can't get employed? We also have a group of students that complete their university degree, also want to get into the market, but for some reason, they either not getting interviews or they're getting interviews and they don't seem to do well. And one of the primary reasons, especially in a networking setup, is the ability to get hands-on experience. So if you can complete these labs, even in a home setup, I can assure you that you can walk into an organization and say, I can do X, Y, Z. And because of that reason, I can comfortably get into the organization and do my job. And many organizations are looking for safe hands. They're looking for people who can work on network equipment, and senior network engineers don't have to worry whether you're going to cause an outage or not, because you're able to configure and you're comfortable with the configuration of devices. So in this video, I'm going to be focusing on the 10 labs that you need to know. It's going to be a long video, so I will put markers so that you can skip to any section that you want. And I'm also going to put a downloadable PDF that is going to include the 10 labs so that you're able to then go and configure them. In the next video, I'm going to walk in step by step configuring the labs, so you can walk through with me so that you can be able to get all the instructions step by step on how to do it. All right, so without taking too much of your time, let us begin. So lab number one, this is basic lab. You need to know how to configure the host name of your Cisco switch or router, how to SSH into the device, configure passwords, management IP, and saving configuration of your devices. Why does this lab matter? Because if you join an organization as a level 1, level 2 network engineer, you're going to be required to set up a device from scratch. How do you open a switch from the box? Give it a management IP address so that you can connect to it remotely. How do you set up your securities to be able to block out-of-band management for VTY and console so that not everyone can configure your device both locally and remotely? How do you even get how do you even get a console cable and connect to the actual physical device? And this is a very important skill set, because many people graduate and finish their CCNA and they've never consoled into a Cisco device. I'm talking about the blue cable, just in case you don't know. They've never plugged in that blue cable into the device. They've never opened, a party or a terminal emulator to be able to then get to the CLI of a Cisco device. So if you can do that, you are basically 10 steps ahead than your other peers that have never done that. So if you can walk into an interview and say, listen, I know how to console into a device, I know how to get into the CLI, I can change the host name. Not that it's very important, but hey, every device needs a name anyway. So if you can change the host name, configure the basic IP settings, then you're going to be a step ahead than the rest of the peers. What is the real world application of that? Deploying of switches in offices, in hospitals. I don't know how many times I get calls and emails from companies over east that are looking for hands and feet in the Western Australia is kind of like separated from the rest of Australia, and in the east that's where you got Sydney and Melbourne, so that's where all the bigger businesses are. And sometimes they might want just a remote engineer who can be able to plug in equipment, give it the basic config in order to be able to get it online so that their own engineers can connect to it, and they're willing to pay for that, for that kind of job. So if you get the skill set, you can be the hands and feet for some of the organizations that might want services done in your particular town if they're not available. Okay, let's go to lab number 2, VLANs and Trunking. I do not have to tell you that VLANs are very important. So in that lab, you need to, create VLANs, delete VLANs, configure access ports, configure trunk ports, and verification of VLANs on your particular network. This lab matters because VLANs are used in every modern network to separate traffic between different departments. And when you join as a network engineer, you are expected to be able to create a VLAN. So you are given, project sheet and say, hey, go and create these subnets, 10 VLANs, blah, 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 blah. You need to be able to go and create those VLANs. But the most important part is trunk links. These are links that connect uplink switches on a network, allowing multiple VLANs to flow through between the access switch and the distribution switch. And in those trunk links, you need to be able to permit the VLANs that are going to traverse that link. That ability of being able to add VLANs and remove VLANs without causing an outage is gold, because every network engineer has probably broken a trunk link because they did not configure the VLANs correctly. I will probably cover that in detail in another video, but I'm just giving you a warning. So if you can do that in a home lab, more than fantastic, so that when you do it in the real world, you do not panic when everything is basically broken. You are comfortable on how to be able to fix it. The whole objective of doing all these labs is so that when you walk into an organization and you make a configuration mistake, you know how to recover yourself out of that problem. Why? Because you have implemented it in a home setup. Whatever you've done in life, once, twice, 3 times, you're much comfortable in being able to do it, and you know how to take your steps backwards. So when you hear people in the networking space making noise about hands-on experience, labs, do it at home, the emphasis is for you to get comfortable so that if anything breaks, you know how to untangle yourself. So let us go to lab number 3. Lab number 3, you're looking at inter-VLAN routing. VLANs are good, they segment traffic. However, you need to talk to other subnets outside of your own VLAN. And for you to be able to do that, you need a layer 3 device. So you're going to look at router on a stick, or you're going to look at L3 SVIs on a switch and the routing verification that is basically involved. This lab matters because VLANs isolate traffic, but you need layer 3 to be able to allow for inter-VLAN communication. And in an organization, you need to connect servers to users. You need to route between wireless and wired networks. And the knowledge that you're going to learn from this lab is going to give you that capability of allowing traffic from multiple VLANs to be able to talk to each other. Router on a stick, very important concept, and an interesting lab to be able to build. So if you can do that, walk into any interview and say, listen, I've configured router on a stick. The moment you say that, we're going to stop. We're going to listen. Why? Because we know router on a stick is a very common theme in Cisco certifications. But if you are able to then document your configuration of that, then man, you get in the job. The job is yours. So I can assure you, get these labs done, you're going to be employable. All right, let's go to lab number 4, static routing. So what do you need to configure? You need to configure static routes, add a route, remove a route, next hop verification. How do you verify the next hop? And having a look at the routing table and be able to identify and ensure that your static routes have actually been injected into the routing table. So those are the things that you need to do. Static routes appear everywhere in the organization. That's why the lab matters, especially on your edge routers, your border routers, or the routers that are facing the internet or the ISP. Real world application, adding routes on firewalls, adding routes on routers, integrating cloud networks, and fixing wrong next hop, because you have the ability to look into the routing table and actually see where traffic is going and correct it accordingly. Static routes are very good, but they've got their own limitations. So you need to learn some form of dynamic routing protocol. And I'm talking about the likes of EIGRP, BGP. But in this case, you need to learn OSPF, because in the new syllabus, OSPF is the standard dynamic routing protocol that is now in CCNA, and which is something that you're expected to know. So in this lab, you're basically configuring OSPF, looking at network statements. How do you advertise a subnet on an OSPF network? How do you establish adjacency with your other peering router? How do you verify that the adjacency is working and the routes are being received? And doing that in a single area. There's multi-area OSPF and single area OSPF, but in CCNA, you need to focus on single area, because multi-area means that it becomes a bit bigger, and that you look at it in CCNP. So you need to build that lab to get your OSPF running, advertise networks on OSPF. Dynamic routing protocols are in every network that you're going to come across. So you're going to come across some dynamic routing protocol in any network that you're going to manage. So learning OSPF gets you to understand how do advertisements take place, how do routers receive subnets, how do you add subnets to a dynamic routing protocol, how do you actually see those subnets being advertised to the adjacent router. So real-world application, adding new networks, fixing OSPF neighbor drops. So we've gone through 5 labs, and these 5 labs, I can assure you, if you do them, you master them, you're able to configure them with confidence. You can walk into any interview and say, hey, before you ask me any questions, I've done these 5 labs. Ask me anything on those 5 labs and I can give you the answers. And yes, they might have 6, 7 other things that you might not know, but if you understand just the labs that we've just spoken about right now, your ability to get the job has probably increased, from 0 to like 70%. And I'm sure by the end of the interview, you're likely going to get the job. Anyway, all right, let's not take too much of a time. DHCP is lab number 6. All of us have encountered DHCP before. If you've ever walked into an airport or somewhere where there was free Wi-Fi and you connected that free Wi-Fi and you managed to access internet, there was DHCP behind that was giving you an IP address lease in order for you to be able to connect to the internet. So every organization has DHCP. There is no organization with no DHCP. So if you're going to walk into an organization, you don't know what DHCP is, you don't know how to configure it, man, it's going to be a struggle for you. Right. In this lab, you need to create a DHCP server on a Cisco router. So configuring the DHCP pools, being able to configure the scope options of DHCP, and I'm talking about DNS, I'm talking about default gateway, or being allocated when someone gets an IP address lease. You need to look at exclusions. How do you exclude certain IP addresses not to be allocated on a DHCP pool? You need to look at DHCP helper, which allows DHCP to reach DHCP servers that are not in the same VLAN as the client that is requesting for an IP address. And lease verification. How do you verify the lease? How do you adjust the lease duration that your DHCP server is basically issuing out to clients? So the lab matters because DHCP breaks quite often. And besides, new subnets need to be created, new IP address pools need to be created, and it is your job as the network engineer to be able to then do that creation. So if you're able to do that in a lab environment, more than good. I would encourage, though it's not in the scope of this video, but also try and configure DHCP on a Windows server, because that's what you're going to likely encounter when you get into corporate space, both Windows and Cisco router. Lab number 7, network address translation. If you ever access the internet, whatever carries your traffic from a local subnet onto a public subnet is network address translation. It does that whole translation for you. So in this lab, you need to know how to configure inside and outside NAT, how to do static NAT, how to do port address translation, and how to verify the NAT table of your devices as they traverse through the network. NAT can be a bit challenging, but once again, if you're able to understand it, configure it, and walk into any organization and say, hey, I can configure NAT, I understand it, this is going to be a huge advantage on your end. So why do we need NAT? Every organization uses NAT. There's no company that does not use NAT. And engineers must understand those translations as they take place on the router. What is the real world application? Internet access for internal networks does not work without NAT. And you need static NAT for servers so that they can be accessed publicly coming into the local network. So if you understand static NAT, you know how the translation basically happens. These are all the good things that you need to know. Okay, lab number 8, access lists. You're going to need to configure standard ACLs, extended ACLs, applying ACLs on interfaces, and troubleshooting ACL order. Access lists deal with control of traffic as it flows through your organization. How do you filter and stop every other user in the organization to access HR servers? You need access control. So wherever you need access control, you need access lists to be able to then do the control for you. So you need to learn how to configure ACLs in your lab, but also what's most important, the direction that you apply the access list is very, very critical. So ACLs have got directions, and those directions are very important. And also ACLs match based on the first order. So if they find a match, they stop looking and they go with whatever they find at the top. So the order is very important. So if you don't get the order right, the ACL is not going to work as expected. And real-world application is restricting VLAN communication, restricting apps talking on the network, and blocking unwanted traffic. All that is going to be done with ACL. So if you are cyber conscious, this is kind of like your section or lab that is going to then deal with that aspect. All right, so 2 more labs to go. Lab number 9, Etherchannel. So when you're connecting uplink switches, if you connect one link, you run the risk that if anything happens to that link is going to break and then you're going to have an outage. So in order to mitigate that, you got 2 cards. You got 2 links. I've got 2 cards, right? One bank on the right, one bank on the left. If I lose this card, I can use this second card as a secondary link. So Etherchannels provide redundancy on your network. Every other network that I know has got some form of Etherchannel that is basically running. So in your lab, you need to learn LACP, PAGP. These are the 2 different protocols that are used for bundling links in an Etherchannel setup. How to create a port channel and load balancing of that traffic and verification of your port channel to make sure that it is working as expected. This matters because every organization requires redundancy and high bandwidth, something that Etherchannels are able to provide for you. And in a real world environment, connecting to your distribution switches, connecting to your core switches, you're going to be expected to create Etherchannels so that you've got that redundancy that is available in the organization. And now to lab number 10. I know I'm not meant to rank these labs in order of any importance, but lab number 10 is very important. And this is basically switch upgrade and config backups. You need to know how to upgrade a Cisco switch and a Cisco router. There are many reasons why you need to upgrade. Sometimes it's vulnerability with a particular iOS image and you need to upgrade, or sometimes it's just a refresh of the features that you want on a particular iOS image. I mentioned before that I had a recent project where I had to upgrade over 500 switches, and when you're upgrading switches in a production network, it can be a bit nerve-wracking because any slip up is going to cause an outage on your network, and you want to make sure that everything goes according to plan. And you don't want to learn how to upgrade switches in a production environment. Trust you me. You want to do it at home, in your own comfort of your home. In the corner of the screen, you can see a switch that is there. Pick yourself one of these and go and upgrade to your heart's content. Downgrade, upgrade, make sure that you're comfortable with the process, because if it happens in production, it's going to be nerve-wracking. Backing up of configs is the next one. You need to store your configs at a remote location so that if you lost the primary config, you're able to then restore. So copying that config to a TFTP server or SCP server is a very important skill set. Very, very, very important skill set. If there's any step or stage where most graduates struggle, it is one of these ones, because it requires an actual device in order for you to practice, right? Most of them, you could cover them through, simulated environment, but this one needs an actual switch. It doesn't need to be expensive. Just get another switch on eBay, $35, $50. Just get a switch or get a router or borrow one from the office if they do have one, and then just copy the image and try and upgrade, because this is very important. So what are the real life examples of why you need this? Performing scheduled upgrades in an organization, backing up configs before making changes, recovering switches after failed upgrades, or migrating from old iOS to a recommended version. All these are going to be scenarios where you're going to need this particular skill set. So I'm sure by now you probably observed that these labs, yes, they're not all the labs that are covered in CCNA, but I can tell you these are almost 80% of what you're going to do in CCNA. This is almost 80% of what you're going to be dealing with on a day-to-day basis. I don't think there's a week that passes by where I don't use any of the 10 labs that I've just basically covered for you right now, right? I have had to upgrade switches recently at work because I was deploying them in a new site that we had, and I wanted to make sure that they are on the latest version so that when I deploy them in the field, they don't get upgraded in the field using SD access, which will probably slow down the whole process. Recently, I was also configuring VLANs. Route on a stick, maybe in a production environment, you don't get to use it that much, but SVIs, you configure them on a day-to-day basis. So what am I trying to say? All I'm just trying to say is that I use these labs almost on a weekly basis, in my role as a network engineer. And if you're going to join any organization, you're probably going to be dealing with most of these labs also, because that's what you do as a network engineer. So if you're able to get these labs, get the hands-on experience, know how to configure them, know how to troubleshoot them, know how to verify them, I don't see any reason why you can walk into an organization that's looking for a network engineer, junior network engineer, and you do not get the job because you are able to demonstrate. So I'm not trying to market this because I'm trying to sell you something. No, I'm just simply saying that I've seen the frustration that people go through when they don't have the necessary skill set to be able to get a job on the market. And it takes longer to get a job because you don't have hands-on experience. And if you do these labs, they're going to give you the necessary experience that's going to make you marketable and be able to get a job because you are employable. So that's it, folks. These are the 10 labs that every CCNA graduate must master in order for them to be employable. As I mentioned, every junior network engineer is going to need to have this knowledge in order for them to succeed. And with 1,000 applications for one job, if you're able to demonstrate this and build a portfolio, then you're 10 steps ahead of your other peers who are graduating without this particular knowledge. So if you're serious about becoming a junior network engineer, then mastering these labs is something that is very important. In the next video, I'm going to be going through the labs in detail, configuring them step by step so that you can follow through and you can also practice in the process. If you've made it this far in the video, I want to thank you for watching and subscribe to get to see more of these videos, and let me know what is it that you want me to cover that can be able to help you in your journey. So once again, thank you for watching, and I'll see you in the next one.